Hello there, welcome back. Today's video is going to be sixth grade math, prime factorization. Okay, so prime factorization is the act of taking a number and breaking it down to its factors, which are numbers that multiply to make that number, all the way down till all the factors we have left for that number are prime numbers. Now remember, prime numbers are numbers where the only way to multiply and get that number is to end up getting 1 times the number itself. That's the only way to make that number. So let's go ahead and do an example. Let's say I need to find the prime factorization for the number 122. Okay, so maybe I'm going to start by making what we call a factor tree. And this is where I kind of just make a diagram of all the factors that make up this number until I'm down to just prime numbers. So since 122 is an even number, I know that 2 is a factor of this number. Now, I don't know what 2 times what equals 122. So to figure that out, I'm going to have to go over here and do 122 divided by 2. Well, 2 does not fit into 1, so I'll put a 0 there. But 2 does fit into 12 6 times. So I'll put 6 up there. 6 times 2 is 12. And when I subtract that, I get 0 left over. I'm going to bring down this 2. And 2 fits into 2 one time. 1 times 2 is 2. And when I subtract that, I get 0 left over. So it looks like 2 and 61 are the factors of 122 that I have so far. So now I need to look at these numbers and decide if they are prime numbers. Well, we know that 2 is a prime number because the only way to multiply and get 2 is to do 1 times 2. So it's definitely a prime number. So I'm going to go ahead and circle that. Now I need to look at 61 and decide if that's a prime number. Now, it's always helpful when you're doing this to have a list of prime numbers by your side, and those are easily found. You can find those in lots of different places. But if you don't have one, you just have to kind of think to yourself, like, is there any way I can multiply and get 61? Now I can multiply something and get 62. I can even multiply numbers to get 60, but I cannot think of any numbers I can multiply to get 61. So that is a prime number. The only way to multiply and get that number is 1 times 61. So this is the prime factorization of 122. It would be 2 times 61. Let's do another example. Let's find the prime factorization of 48. Okay, I'm going to start by breaking 48 down into 2 numbers that multiply to get 48. I have lots of choices here. I can do 2 because it's an even number. I even think I can do 3. I could do 4. I could do 6. I could do 8. So I'm just going to put down the first 2 factors that come to my mind when I see 48. And that would be 6 times 8. Now, if you chose a different set of factors to start with, that's okay. Once we get down to prime factorization, our answer should be the same once we break it all down. So looking at the number 6, I realized that that is not a prime number because I could do 1 times 6 to get 6, but I could also do 2 times 3. So that is not a prime number, which means I need to break it down even more. And like I mentioned, 2 times 3 does give us 6. So I'm going to go ahead and mark those down. When I look at the number 8, yes, I could do 1 times 8, but I could also do 4 times 2. So that's what I'm going to use here to break that down, 4 times 2. So now I'm going to look at what I have so far to see if I can find any prime numbers. So the numbers I see that look like prime numbers to me are 2 and another 2 here and 3. All of those numbers are prime because the only way to multiply them and get that number is to do 1 times 2 or 1 times 3. Now, the only number I have left that is not a prime number is 4 because I could do 1 times 4, but I could also do 2 times 2. So that's what I'm going to break this 4 down to. Now, when I look at what I have here, I have 2 2's, which I know 2 now is a prime number. So this is the prime factorization for 48. I can write it in 2 different ways. I can either write it as a multiplication expression, or I can write it as a multiplication expression using exponents. So if you're familiar with exponents, you can use these here as well. So I count 1, 2, 3, 4 2's. So I'm going to write the prime factorization as 2 times 2 times 2 times 2, and then there's a 3. So I'm going to go ahead and put that 3 there. So if you wanted to say this was your answer as the prime factorization for 48, you would be correct. Another way to write it, a little bit simpler if you have experience with exponents, is to take all those twos and rewrite them as a power. So I'm going to take that right here. Since the base would be 2, and we're multiplying 2 by itself 4 times, that's 2 to the 4th power. But I would need to include the 3, because even though the 3 doesn't have another number that I can, or another 3 that I'm multiplying it by, it's still part of the prime factorization. So your answer could be this expression right here, 2 times 2 times 2 times 2 times 3, or it could be 2 to the 4th power times 3. Both of those expressions are equivalent to each other. Okay, let's do this example together. What is the prime factorization of 9? Okay, well, let's start by putting 9 here. And when I think about 9, I know that I can multiply 1 times 9, but I could also multiply 3 times 3. So I'm going to go ahead and put that down here as my two factors. So now I need to look at them and decide if they are prime or if they are not prime. So the only way to multiply and get 3 is to do 1 times 3. So I'm going to go ahead and circle that as prime and circle this as prime. So I could rewrite my prime factorization as 3 times 3, or I could write it as 3 to the 2nd power because both of those are equivalent. Here is our next practice problem. What is the prime factorization of 4? Okay, well, let's start by writing down 4. And when I think of 4, I think of 1 times 4, and I think of 2 times 2. So I'm going to go ahead and write a 2 here and a 2 here. And I know that 2 is a prime number because the only way to multiply and get 2 is to do 1 times 2. So I'm going to circle both of those as prime. And I have no more numbers to bring down. So that means I'm finished with the prime factorization. I just have to rewrite it as 2 times 2 or 2 to the 2nd power. Our next practice problem is going to be the prime factorization of 45. Okay, so let's write 45 up here. And the first two numbers I think of that multiply to make 45, besides 1 and 45, are 5 and 9. So I'm going to go ahead and write those here, 5 and 9. Well, 5 is a prime number because the only way to multiply and get 5 is to do 1 times 5. So I'm going to go ahead and circle that. But 9 is not a prime number. I can do 1 times 9, but I can also do 3 times 3. So that's what I'm going to break the 9 down to, 3 and 3. Now I know 3 is a prime number, so I'm going to go ahead and circle both of those. And if I have nothing left to break down, that means I'm finished with my prime factorization. So I could rewrite that as 3 times 3 times 5, or I could rewrite it as 3 to the 2nd power times 5. Okay, here's our next practice problem. What is the prime factorization of 42? Okay, so let's write 42 here. Now, there's a couple different factors I can think of for 42. There's 1 times 42, which doesn't help us because it doesn't help us break it down anymore. There's also 2 times 21 because it is an even number, so we know 2 is a factor. There's also 6 times 7. So that's the one I'm going to use because that's the one I think of the most when I see 42 is 6 times 7. Okay, well, 6 is not a prime number because I can do 1 times 6, but I can also do 2 times 3. So I'm going to go ahead and break that down to 2 times 3. Now, 7, I cannot break down any further. The only way to multiply and get 7 is to do 1 times 7, making it a prime number. So I'm going to circle that one. Now, 2 is a prime number and 3 is a prime number. So all of those are now circled. That means I've finished my prime factorization. I just need to rewrite it. So I would write this as 2 times 3 times 7. Now I can't use any part of this as an exponent because I don't have any prime factors that are repeating themselves or being multiplied by themselves. So the prime factorization for this one would have to be 2 times 3 times 7. Okay, here's our last practice problem for this video. What is the prime factorization of 17? Okay, so I'm going to write 17 here. And as I start to break it down, I can't think of any numbers that besides 1 and 17 that multiply to make 17. So I can either break it down to 1 times 17 and then write that as my prime factorization. Or I could just write prime. It's a prime number. It can't be broken down any further. All right. Well, thank you so much for joining me today. I hope to see you in another video soon. Thanks.